All right, we're going to finish chapter 4, section 3 by writing equations of hyperbolas, right? So this is 4.3f, right? So our very last part of this section, all right? As always, right, you guys have seen this before from writing equations of parabolas and ellipses. I do it pretty much the exact same way. I draw the picture from my little picture or from the information given. I just determine which equation to use. You find the center. If it's at 0, 0, you have kind of a simpler equation. If it's not centered at 0, 0, you just use the variation that has the h and the k. And you look for your a and b values, and then you plug them in accordingly, right? You guys are going to see it's the more you do these, the more repetitive they get, and you see that it's really no different from anything else that we've been doing. All right, so let's just start. So again, as always, I like to draw a little picture. Some of you in class were saying that you can get away without drawing a picture, like you were able to do it without. That's perfectly fine. I prefer drawing the picture just because it's easier for me to visualize the information, right? So let's start with our foci, right? So I have 3, 0, 1 right there, and then negative 3, 0 somewhere right there. We also have vertices at negative 2, 0 and 2, 0, so a point right there and a point right there. All right, because these are where my vertices and foci are, I know that this is going to open side to side. So that means it's an x squared hyperbola, meaning it's going to be x squared over a squared minus y squared over b squared equals 1. We just need to find our a and b values, right? Our a value is going to be from the center to your vertex, right? Or each of your vertices. And I knew my center was at 0, 0 because the center is always equidistant from your foci and your vertices, right? So that point right there is exactly 2 units from each of your vertices. And that also gives us our a value, right? I know that a has to equal 2, right? And that would make a squared equal to 4. So that means I'm going to put that into my equation, replace that a squared with a 4, all right? The only thing left is to find our b squared, which our b squared we can get from, if we don't have any information given to us, we can use this little formula, c squared equals a squared plus b squared. And remember, c is going to represent the distance from your center to your foci, or your focus, right? So it's going to be c, or I guess this is negative c and this is c, right? So that means your c value is going to be this distance, so 3 units and 3 units. So I have c equals 3, and so c squared is going to equal 9. All right, so let's plug in all of our information. I have 9 equals 4 plus b squared. All we have to do is subtract 4 on both sides, and I get 5 is b squared. And then you're going to plug in 5 for b squared. And then that's going to get us our formula. Our equation. And that's all we have to do with that one. All right, let's keep it going. All right, so our vertices at negative 1, 0 and 1, 0. So negative 1 is going to be right there, and 1, 0 is going to be right there. Those are my vertices. That just means my center is directly in between it at 0, 0. All right, so I already know that the distance from my center to the vertex is an a value, and so I know a has to equal 1, and that would make a squared equal to 1. I also know that because my vertices are on the x-axis, it's going to open side to side like that, and that would make a squared with the x squared, and then b with the y squared, all right? And then I can just go ahead and plug in that 1. It's going to go somewhere right there, right, over 1. The other piece of information that we're given are the asymptotes. I have negative 4x and 4x, right? So probably something like that, and then probably something like that. It's not that important that we sketch the graph. What you should know is your formula for the asymptotes of a hyperbola. And in a hyperbola, it's always going to be plus minus whatever's with the y over whatever's with the x, and then x as your variable, right? In this case, b is with our y, so it's going to be b over a x, all right? And so I know for sure that this b over a has to equal 4, right? If I have a negative 4x and a positive 4x, I know it has to be plus minus 4. So I know for sure that b over a has to equal 4. And because I already know that a equals 1, I have that b over 1 equals 4. And then when you go to simplify that, we have b equal to 4. All right, so that means we can, from here, find our b squared value, and that would make b squared equal 16. And then I would just plug that into my equation for b squared, and then we would get something that looks like this. All right, if you don't like the 1 underneath, right, it's a little redundant, you can just get rid of it, and then you can say that this is just x squared minus y squared over 16 equals 1. All right, and that's really all we have to do for that one. On to the next. All right, this one we're given new information. We're given foci at 0, -5, and 0, 5. Once again, just get a rough idea of what it looks like. 0, 5 is going to be up 5 units. 0, -5 is going to be down 5 units. And I know my center is always in between, so it has to be at 0, 0. All right. Another thing that I know is that since these are my foci, these are my c values. So that means c is going to equal 5. C has to be 5 units, right? What else does this tell us? This tells us that our hyperbola is going to open up and down, right? I don't know exactly where it's going to hit the y-axis, but we do know that it's a y squared hyperbola. So that means I'm going to have a y squared over a squared minus x squared over b squared equals 1, all right? So if I have c equal to 5, all right, that would make c squared 25. All right, why is that important? Because we don't have an a or a b here, but we do have asymptotes, right? And remember, since a is with the y, that would make this equation plus minus a over bx, right? And in this case, a over b has to be 3 over 4. So let me just write that down over here, right? We know that a over b has to be 3 over 4, all right? So then when we go to plug into our formula, I have that c squared equals a squared plus b squared. I'm going to have 25 equal to, let's just see if this matches, right? So if a over b has to equal 3 over 4, then I know that a has to equal 3 and b has to equal 4. And then you really should be confirming this information with that formula, right? And I'll show you what that means, right? So you really should be plugging in 3 squared plus 4 squared and making sure that this is a true statement. So we get 25 equal to 9 plus 16, and then this is true. So that means A is indeed 3 and B is indeed 4. And that would make these 3 squared, which is 9, over B squared, which is 16, right? Why did I tell you guys to plug it in, right? Even though you clearly can see if what's on top matches with the top, the bottom matches the bottom. That is true. They are going to match, just sometimes it's going to vary by a different factor, right? So let's say 3 over 4 was simplified. Let's say our A was actually 6 and our B was actually 8, right? You wouldn't have known that unless you plugged it into your formula, right? Let's say, for example, your foci were at 0 comma plus minus 10, right? That would make c squared equal to 100. And then when you go to plug in 9 and 16, that's not going to get you 100. But if you double them by a factor of 2, right? Well, doubling is by a factor of 2, right? But then you would have gotten 6 squared plus 8 squared, which is 36 plus 64, and that would get you 100, right? So that's just something to be mindful of. It didn't happen in this problem. I think in one of these set of notes it does happen, right? So just something to be mindful of, right? That wasn't part of our problem, but something to be mindful with the asymptotes is that they're always going to be simplified, And it does tell you where A and B are, but it doesn't tell you the exact number unless it matches with the information that you get from your C squared value. All right, so just something to keep in mind. Otherwise, that's it for that problem. All right, so let's try the same thing here. I have vertices at 0, -2, and 0, 2. So 1, 2 up, 1, 2 down. And that means I know it's going to open something like that. I know it's going to be a y squared over a squared minus x squared over b squared equals 1. All right, and then I also know my center is at 0, 0. So that means my a value has to be 2, and that would make a squared equal to 4. So I can go ahead and replace that a squared with a 4. All right, we also have that it passes through -2 and 5. That would make that x and that y. All right, so then we're going to plug in all of that information, and we're going to solve for whatever's missing, which is b squared. All right, so I get a y squared, so 5 squared over 4, minus x squared, so minus -2 squared over b equals 1. And that's going to get us 25 over 4 minus 4 over b equals 1. I'm sorry, not b, b squared. Sorry, don't forget the square. And then we want to get the b squared by itself. Right? So I can go ahead and subtract 25 over 4 from both sides. And then to do that here, we would change this 1 into a 1 over 1, and then make it a 4 over 4, right? And then 4 minus 25 is a -21, so we end up with a -4 over b squared equals -21 over 4. All right? And then you can cross multiply, like how you would do in Algebra 1. And then we get -21b squared equals -16. And then all you have to do is divide both sides by -21, and we get b squared is 16 over 21. All right, I don't need to square root both sides and like rationalize the denominator and all that, because that is exactly what we need in that formula. So I'm going to replace that b squared with, it's not letting me erase, hold on. Okay, with 16 over 21. And then that's perfectly fine. Another thing that you can do is keep change flip it so that it looks a little bit prettier, and get y squared y squared over 4 minus, right, keep the first, the x squared, change the division of multiplication, and flip 16 over 21, and that's going to get you 21 x squared over 16 equals 1. And then that's also acceptable. All right. But the hardest part here is really the cross multiplying, right? It shouldn't have been anything conceptually, right? As always, if you draw the picture and understand the information, then you should be able to pull your information pretty easily. All right. So let's look at this one. Now I have x-intercepts at ±3, 0. Now, whoa there, right? This one's a little bit different. We haven't talked about x-intercepts. But we do know that we have foci at ±5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. That means I know it's going to open in that direction. I know it's going to be a left and right hyperbola. And I also know that my center is at 0, 0. Right? It's always between the foci. Right? Why does that matter for your x-intercepts? Well, look what happens when you plot them. Right? What do those look like on your graph, right? What do we call those? Like, let's say our hyperbola is actually going outwards from those 2 points. What do we call those? All right? Those are our vertices, right? Our x-intercepts in this case are also our vertices. All right? So it's important that if you're drawing that picture, you would have recognized that. Just by looking at the words, that could confuse some people, right? I can see how that's confusing, because I told you guys we don't really need to find specific points here to like graph your hyperbolas or anything, really. You just need to know some key information like the vertices and the asymptotes. And so when you're given something that's called something different, that from what you're used to, right, you might freeze a little bit and you might not know what to do with the information. But you can see clearly when we plot it that clearly gives us our vertices, all right? And so that's going to give us our A value, which from the center to our vertex is going to be 3. And so that would make A squared 9. All right, another piece of information that we have are our foci, right? From here to your focus, it's going to be a C unit of 5, all right? And that would make C squared 25, all right? Because it's opening left and right, and my center is at 0, 0, I know it's going to be x squared over a squared minus y squared over b squared equals 1, all right? I already know a squared is 9. We just found that. Now we need to find our b squared, right? Our b squared we can get from using this little formula, c squared equals a squared plus b squared, and c squared in this case is 25. A squared is 9 plus b squared. All we have to do is subtract 9 on both sides, and I get 16 equals b squared. So then what I do with that 16, plug it into our equation. And I'm going to replace b squared with 16. And then we get something like that as our final answer. All right, same exact story with this one. All right, so let's plot the information. All right, y-intercepts, okay, we saw that last problem, right? Might have been a little scary for the last one, but this one shouldn't really phase us at this point, right? We can clearly see if we go up 9 units, somewhere right there, right? And then down 9 units, somewhere right there. It doesn't need to be perfect. You just need to know what the information looks like. And I have foci at plus minus 15. All right, I don't really want to count to 15. It's going to be somewhere right there and then somewhere right there. All right, so I know for sure it's going to look something like that. So I know it's going to be an up-down hyperbola. And that means it's going to be y squared first. So y squared over a squared minus x squared over b squared equals 1. We can find our a value from counting our distance from the center to our vertices. And I know since it's at plus minus 9, my a value is going to be 9, which makes my a square valued 81. All right. And then my foci at plus minus 15, that would make my center to the focus a c value of 15, which c squared would be 225. All right. And then all we have to do from here to find b squared, plug it into our formula. C squared equals a squared plus b squared. And so we end up with 225 equals 81 plus b squared. And then we subtract 81 on both sides. And then we end up with 144. All right. We don't really need to know what b is. All I need to know is that b squared is 144, and then I can plug that information in. Right, I have that a squared is 81. We found that one of the first things that we found. And then I have that b squared is 144. We just found that based on the information that we were given. All right, so hopefully you guys are seeing, right? It's not too bad. All right, so try some more problems, right? I have vertices at plus minus 10, comma 0. All right, so let's plot those, right? 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. 1, 2, 3, 4. I'm cutting into the edge of my screen here, right? Probably shows different for you guys, but I'm cutting into the edge of my screen. Okay, whatever, right? I don't really need to be super precise, right? I just know that it's going to look something like that, right? Not the prettiest thing. It's fine. Doesn't really matter. But we do know for sure that my center is directly in between it at 0, 0. And I do know that that distance is going to be 10, and that would make a squared 100, right? I also know that since it's opening left and right, it's going to be an x squared hyperbola, so it's x squared over a squared minus y squared over b squared equals 1, all right? And then we just found a squared, so I'm going to replace it with 100. The other thing that we need is our b value, but we have asymptotes, right? And remember, since it is a horizontal hyperbola, b goes with y, and that would make this asymptote equation, it's going to be plus minus b over a, right, x, all right? So that means that b over a has to match that 5, All right, so let's do b over a equals 5. All right. Now I know for sure that a is 10, so all I have to do is replace that a with 10, and then I solve for b, right? Times 10 times 10, and I get b equals 50. And then b squared, big number, guys, right? So think of it a couple ways. If you don't want to do 50 times 50, right? You have 2 zeros when you end up multiplying this, and we know that 5 times 5 is 25, right? So 25 plus 2 zeros is going to be 2,500. All right, so I'm going to take that number, plug it right into my equation, and I know, it's not erasing again, all right? Know that this is going to be 2,500. All right, so it's going to be a pretty big hyperbola if we were to graph it. All right, so this probably isn't something that we would ask you to graph. It would just be to write the equation, right? I don't expect you to go 50 units up and down, right? But otherwise, that's it. That's how you find that one. All right, so let's try some more. This one has vertices at 0, -5, and 0, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So those are my vertices, and since those are my vertices, I know that it has to open up and down. Right? You're probably seeing with these that my drawings are getting progressively worse, right? Doesn't really matter, because all the drawing is there to help us. All the drawing is helping us with is visualizing our information and knowing which equation to use. All right, so I know my center has to be directly between those, and that would make my a value 5, and that would make a squared 25. All right, since it's up down, I know that y squared has to be first, so it's y squared over a squared minus x squared over b squared equals 1. So then I can go ahead and replace that a squared with 25. I have that it passes through 310, so I know that that's going to be an x and a y. All right, this is kind of an annoying one that you have to like plug in your numbers and then solve a proportion, that sort of thing. So I'm going to replace y squared with 10 squared, and I know that 10 squared is 100. So this is going to be 100 over 25 minus x is 3. That's going to make x squared equal to 9. So minus 9 over b squared equals 1. And then 100 over 25, right? Simplify that as much as you can. That's going to get you a whole number 4, right? So this is actually a pretty nice problem. Equals 1. And then we are going to subtract 4 on both sides. Thankfully, I don't have to convert any fractions here, so it shouldn't be too bad. Equals 1 minus 4 is -3. But I still have b squared on the bottom, so it might be a little bit better if we did cross multiply anyway, so I'm going to do this over 1. All right, sorry guys. All right, we still should probably do it just to make it a little bit easier. All right, let's cross multiply, and I get -3b squared equals -9. And then let's divide both sides by -3, and then we get b squared is 3. I don't have to square root and get square root of 3 because all I have to do is replace that b squared with a 3. And then that's the equation of your hyperbola. All right, 2 more examples in this set of notes, and they're fairly challenging, right? So let's just have a look at this one. We have foci and we have asymptotes, right? So let's graph our information. Plus minus 3 square root of 5. I have no idea where that is, right? But you don't need to, because I know that it's on the x-axis. It's a number comma 0. That means my foci is going to be right there and right there, which means my vertices are going to go that way. Again, not a pretty picture. That's fine. All you need to know is that this is an x squared hyperbola. So it's x squared over a squared minus y squared over b squared equals 1. And then what we can find from here are our c value, right? I know that from here to here, that's a c value of 3 square root of 5. So that means when I do c squared, that's 3 square root of 5 squared, right? So we actually have to do a little bit of math to find this one. Distribute that square, and I get 3 squared, which is 9, and then square root of 5 squared, which is 5. So then I get c squared is 45. All right. And then so what can we do? I have that c squared equals a squared plus b squared. The only way that we can get a and b are from our asymptotes. So I know that since this is a left-right, it's a horizontal, b is with the y, and so that would make plus minus 2x. That 2 has to be b over a, right? Because we're basing this off of the fact that this is a b over ax asymptote, right? So then I have 2 equals b over a, all right? And that would make 2 over 1 equal to b over a, all right? So that means 2 corresponds with b and 1 corresponds with a. All right, now how are we going to do this, right? Still can't really figure out which is which, because if I tried to do it I did in a previous problem, and I just said, okay, well, b should go with the top one, so b is 2, a should go with the bottom one, then we get b squared is 4, and a squared is 1, but 4 plus 1 is not 45. All right? A little bit of a trickier one, this one, right? So let me go ahead and erase that. That's not going to help us here. Something that we can do is let me multiply a on both sides, right? Then I get b equals 2a. You're probably like, okay, well, how does that help us? Well, if I try to plug in the information that I have, right, I'm going to plug in that 45 for c squared. I don't really have anything for a squared, but we just said that b equals something, right? It's not quite a number, but it equals something. So I have b equals 2a. I can go ahead and replace that b with 2a. So this is going to get me a squared plus 2a squared, right? And then now we only have an equation in terms of a. So this actually should be pretty easy to solve, right? And actually solving it is not hard. The hard part was figuring out to make this little substitution so that you can plug that in there, right? And then when you go to solve this, this is going to get you 45 equals a squared plus square each of these. You're going to get 4a squared. So we get 45 equals 5a squared. Divide by 5, and I get a squared is 9. That helps us a lot, right? Because now we can plug this into our original formula and say that this is x squared over 9. And then I can plug that into this a squared to find that b squared. So then we end up with 45 equals 9 plus b squared. And when you subtract 9 on both sides, we get 36 equals b squared. All right? And then so what I'm going to do is I'm going to plug that into that formula, and then that's going to get us 36 underneath the y squared. And then that is our final answer. All right? So a lot of thinking that had to be done. You could have, let's just say from here, is you could probably just guess, right? Okay, what's another equivalent fraction to 2 over 1? Right, maybe 4 over 2. And then if let's just say b squared equals 16, a squared equals 4. Okay, 16 plus 4 gets you 20. That's not close, right? 6 over 3 also gets you 2 over 1, right? So that could work. And then b squared would get you 36, and a squared would get you 9. And that does get you 45, right, when you add those together, right? So you could guess. I mean, there's nothing really wrong with that, but this is a mathematical way to actually get the answer besides just guessing, right? So a little bit more challenging, that one, right? So should have hopefully made you think a little bit harder than some of the other ones, right? So not as straightforward. You had to kind of do some loops to actually get your final answer, right? But there's the more complicated but mathematically correct way to do it, or there's this on the side where you just guess, right? If I already know that the fraction is going to be 2 over 1, 4 over 2, 6 over 3, 8 over 4, 10 over 5 are all going to get you 2 over 1, right? So you can just guess any of those and see which one works. All right, let's try one more. I have vertices, right? You can probably already tell based on your vertices, this is not going to get you a center at 0, 0. All right, so 1, 2, 3, 4, 5, 1, 2. And then 1, negative 2 is going to be right there. So those are my vertices. I know it's going to open something like that. And that would make my center directly in between the two. You could figure it out based on counting, or you could look at what else they give you. They give you asymptotes. Now, if you remember with asymptotes, the only difference between the two formulas for a horizontal or vertical hyperbola was the b over a and the a over b. This is still going to be k, and that is still going to be h. So you can very simply just look at your asymptotes, and you can see that your h is going to be 3 and your k is going to be negative 2. So that center right there is 3, negative 2. All right? And that would make this an x minus h squared over a squared minus a y minus k squared over b squared equals 1. And then we can go ahead and plug in our information, right? I already know that h and k are going to be 3 and negative 2, respectively, right? So x minus 3 and y plus 2 squared. All right, what else can we figure out? We can figure out our a value, right? From the center to your vertices, that's 2 units. So a squared has to equal 4. I can go ahead and replace that a squared with a 4. What else can I find? Well, we know this right here, this 3 over 2 represents either b over a or a over b. And since the b squared is with the y, I know that b has to be on top. So I know that 3 over 2 has to equal b over a. All right. And then that a value we just found, right? It's 2. And then we just solve this equation for b, right? So I'm going to multiply both sides by 2. And then we get b equals 3. And that makes b squared 9. So I'm going to replace that b squared with 9. And then that fills in all of our necessary information, right? Only difference here, we had a center, but again, derive the necessary information that you need from the information that you're given and from the little picture that you're drawing. All right, so you can see I kind of went through these a little bit quickly, but that's just because these get fairly repetitive after a while, right? Some of them, again, are a little bit challenging, but that's to be expected with questions of these nature, right? You're going to be given various information, and you need to choose the best course of action to find what you need to find.